Hey math kids, today we're going to do graphing quartic functions, and it's pretty similar to the previous video. Really the only thing is if our a value, so quartic is like to the fourth, and if a is greater than 0, you're going to have something like this or this, like both ends point up. If a is less than 0, both ends point down, so it could be something like that. Okay. The other stuff is pretty much the same. So we'll start with this. Okay, we'll start with the X-Intercepts like we did previously. So hopefully you can start to get in the habit of seeing what this is without like setting it equal to 0 and solving. So we would add this over, so it's a positive 2, and then divide by 3, so it's 2/3. -3, -1, -1. So this is -1 with a multiplicity of 2 is sometimes how you hear it worded. Okay, so we have this and this. And so at -1, we're just going to touch. -3 will go through, and then 2/3 will go through as well. We also want to find the Y-intercept. And so Y-intercept, we'll plug in zeros for all the x's. So that leaves us with a -2, +3, and a 1 being squared. And so that's just 1, so that's just -6. Okay. We also know there's technically a 1 out here, so our a is greater than 0. So it's going to be this situation. So remember, this one has the multiplicity on it, so we're not going to go through. So we'll go like this, 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 this. So something like that. Once again, we don't know how low it goes, because we didn't specifically find it where the max and the min were. Okay, now we're going to try another one. Okay, so X-intercepts, we have 3, 3, -2, -2. Y-intercept, plug in a 0, plug in a 0, we're going to get -3 squared and 2 squared. So that's going to be 9 times 4, and so we get 36 on that one. And this negative sign is out in front here, so I should have carried that down there, and we got the -36. Okay, let's plot everything on here. Okay, 3, that has multiplicity. That also has multiplicity. Then I'll go 5, 10, 15, 20, 25, 30, 35, and so a little bit more, 36. Okay, since the a is negative, it's a -1 out in front, right there. We're going to have something that goes like that. And since both of these have multiplicity, meaning multiple of the same, we're just going to touch there, come down there, touch there. And it'll look something like that. Okay, now it says find the equation of the quartic with this graph. So I will do my best to draw this graph. Feel free to look in your book though. Okay, so we're just going to do kind of in reverse what we did on the previous problems. So we know we're going to get x plus 3 from this. We're going to get x plus 1 from this. So I'm changing the signs. And then we're going to get x minus 3 from this. Now, we also know, actually, this minus 1, which is the plus 1, that'll be squared because it doesn't go through. Again, we have our 1, 2, 3, 4, so that's our quadratic, or our quartic, and then we will probably have a scale factor out in front, and that's equal to y. So all we have to do is find that, that value, and we can do that using the y-intercept. So when we plug in 0 for x, we'll get negative 3 for y. So negative 3, and then plugging in a 0 just leaves the 3, plugging in a 0 leaves 1 squared, plugging in a 0 leaves negative 3. Alright, that's just 1, that's negative 9a, divide by negative 9, divide by negative 9, negatives cancel, and that leaves 1/3 for a. And so we come back up here and change that to 1/3, and that's the equation of our Quartic function. Okay, one more example. It says find the Quartic function p of x, which touches the x-axis at 2. So it touches, so that tells us we have at least two of our roots. Cuts the x-axis at negative 3 and passes through these 2 points. Okay, so we can set up our function. We know a couple things about it. So we can say p of x is equal to x minus 2 squared. We have 2 at 2. And then we also know x plus 3 from this one. And then since we only have 1, 2, 3, we need another linear factor. So we're going to set it up like that. Now from here, all we can do is use the 2 different points. So when I plug in 1 for x, I need to get negative 12 for p of x. So we get negative 12, 1 minus 2, 1 plus 3, a times 1 plus b, and then just kind of go through simplifying this. So it's negative 1 squared, 4, a plus b. That's just going to be positive 1 times 4, so it's 4, a plus b, and divide by 4. So a plus b is equal to negative 3. Okay, so we'll be able to use that. Next thing we want to do is plug in 3 for x, and we'll get 6. So I'm just going to erase this work, keep that final equation. So we'll plug in 3, and we should get 6. So 3 minus 2 squared, 3 plus 3, a times 3, and the answer should be 6. 3 minus 2 is 1, 1 squared is 1. That's going to be 6. That's going to be 3a plus b. This is really just 6, so I'm going to divide both sides by 6, and so 3a plus b is equal to 1. Alright, get rid of that. Now we just need to use these two equations to solve for a and b. So probably the best thing to do is use elimination. So what I'm going to do is I'm going to go through and multiply everything by a negative, which changes all those signs. add them together, b's cancel, and we can see that a is equal to 2. And then if we just take that, plug it into either of the originals, so I'm going to plug it into the yellow one. So I get 2 plus b equals negative 3. Subtract 2 from both sides, and b equals negative 5. And the last thing to do is to modify the original. So get my eraser, change a and b. So what was A was 2, b was negative 5. And then this would be the equation of that quartic. If you need additional help, please come to Math Lab and tell them